Okay, everybody, so thank you again to Dr. Frost for these wonderful PowerPoints. I'm really sorry, I forgot to change the thing. This is, in fact, Pure 4, Chapter 2. Okay then, so, partial fractions. So, we can split this fraction up, okay? But this doesn't just mean that this fraction now equals 6x over x minus 3 minus 2 lots of x plus 1. Okay, and what we're going to do is we're going to see why this doesn't just equal that. If we were to add or take away these fractions, what would we first do? And actually, we would first have a common denominator. So I would multiply the left fraction by x plus 1 over x plus 1, and the right fraction by x minus 3 over x minus 3. And then what you'd find is that on my numerator, I'd get 6x bracket x plus 1 minus 2 lots of x minus 3 all over our common denominator, which we have here. Now, if I was to expand and multiply this out, you can see straight away we're going to end up with a 6x squared. And this isn't going to simplify because on this side we're not going to have an x squared. In our original question, we do not have a 6x squared. This is not allowed. So we are not allowed to do this. Okay, that's not how fractions work. We can't just simplify it. And I know sometimes when we start looking at algebra, people forget and they think, you know, it is a bit more abstract, maybe we can do that. But if you were to think about this in terms of numbers, this isn't something you can do, okay? So there's two different methods that you can do. I'm going to show you both methods. Then on the next question, we're going to do it again with both methods, and then you're going to decide which method you prefer, okay? Because, you know, when in doubt, give it all a go. So, first method is substitution. So we know that these three lines mean this is completely equivalent to this, okay? They are identical. So whatever x is on this side, it's completely equal to this side. This is why we can do this. Now, the first one is called substitution. Now, before we can start substituting any values in, what we're going to do is get rid of the denominators. Now, if we multiply everything by x minus 3, and what I'm about to show you don't have to write down. I'll highlight the steps which are the minimum requirement. But if I multiply everything by x minus 3 and x plus 1, I'd get 6x minus 2 bracket x minus 3 x plus 1 over x minus 3 x plus 1. Now this is going to equal a bracket x minus 3 x plus 1 over x minus 3 plus b lots of x minus 3 x plus 1 all over x plus 1. Now it's clear to see here that these x minus 3 is going to cancel and the x plus 1 is going to cancel. X minus 3 is going to cancel here because obviously it's a factor of the numerator and denominator, and x plus 1 are going to cancel here. So what we're going to be left with is 6x minus 2 equals a lots of x plus 1 plus b lots of x minus 3. Okay, this step you definitely have to write, and let's highlight it in a nice colour. Okay, so this is a step that you will have to write. You do not have to write that step before, but that's to show you how I've got to this stage. Now what we're going to do is we're going to use substitution. We're going to let x equal whatever it needs to be to make this bracket 0. And the same here, so that we can then solve it. So for example, anything after this you now have to write. If I let x equal negative 1, then I'm going to get 6 lots of negative 1 equals, minus 2 equals, now Okay, you don't have to write this bit, but I'm just going to write this in there. A lots of minus 1 plus 1, and then plus B lots of minus 1 minus 3. So you know that the A lots of minus 1 plus 1 is going to cancel. Okay, this is going to mean 6 lots of minus 1 is minus 6, minus 2 is minus 8. A is going to be multiplied by 0, so that cancels, and B is going to be multiplied by minus 3 minus 1 is minus 4B. So that means B equals 2. And then we're going to do the same. We're going to let X equal our other bracket, which is 3. So we're going to have 6 lots of 3 minus 2 equals A lots of 3 plus 1. I'm not going to bother writing plus B, 3 lots of minus 3, because we know that's going to cancel. 6 lots of 3 is in fact 18, minus 2 is 16, equals 4A. So therefore A equals 4. So that means that 6x minus 2 can be written as over x minus 3x plus 1 can also be written as 4 over x minus 3 plus 2 over x plus 1. Now again, something to take note of. Here, you know where we multiplied them by x plus 1 and x minus 3. If I was to do the same here, I would then, my numerator would then simplify to 6x minus 2. This is completely equivalent, okay? So method 2 is comparing coefficients. So we get to the pink step. 6x minus 2 equals A lots of x plus 1 plus B lots of x minus 3. Okay, so we're at this step. Now what we can do is expand out and then compare coefficients. So what I mean by that is 6x minus 2 equals ax plus a plus bx minus 3. Now if I just rearrange this right hand side, I'm going to have ax plus bx, oh sorry, this is 3b, plus a minus 3b. And then if I take out a factor of x, I'm going to have x lots of x plus b plus a minus 3b. So what we have here is when we compare coefficients, is we know that 6 must equal a plus b, because it's the coefficient of x, and that minus 2 must equal a minus 3b, because this is the term without any coefficients. So we have 6 equals a plus b, and then we have minus 2 equals a minus 3b. So what we have here is a set of simultaneous equations that we could solve. I could take them away from each other. 6 minus minus 2 is 8. A minus a is 0. B minus minus 3b is 4b. So therefore b equals 2. I can substitute b equals 2 into 6 equals a plus 2. That means that 6 minus 2 equals a. So a equals 4. Therefore we can rewrite our fraction. And at the end you always have to do this last statement, and I know it feels like you're writing a lot, but you just have to do it because we have to show that they are completely equivalent. And we're going to get 4 over x minus 3 plus 2 lots of x plus 1. So here we have two different methods that obtain the same answer. So here we have another example. And this time what we're going to do is we're going to do it both ways. So we're going to do substitution and comparing coefficients. If you feel confident, get started. We're going to do substitution first. And then we're going to do comparing after, okay? But if you feel confident, give it a go. So with substitution, again, now, with this bit, you could multiply and cancel it all out, but I know if I multiply this denominator by a, my a is going to be left with x minus 1 and 2x plus 1, okay? So I know straight away that 6x squared plus 5x minus 2 equals a lots of x minus 1, 2x plus 1, plus b lots of x lots of 2x plus 1. Maybe I should have written, okay, I'm going to start again. I'm going to zoom in, everyone. Okay, here we go. Right. I'm going to make it a bit smaller. Okay, so 6x squared plus 5x minus 2 equals a lots of x minus 1, 2x plus 1, plus b lots of x, 2x plus 1, because obviously if I multiplied this denominator here, the x minus 1 and the x minus 1 would cancel, plus c lots of x, lots of x minus 1. And again, you can see if I was to multiply this denominator up here, the 2x plus 1 would cancel. So now that I have that, substitution, I'm going to have a look. I have 3 values for x, which would make each bracket 0. I have x equals 1, x equals minus a half, and x equals 0. And where did I get those from? Well, x equals 1 comes from here. When I substitute 1 into this bracket, I'm going to get 0. When I substitute x equals minus a half into this bracket, I get x equals minus half. And then if I substitute x equals 0 here, of course, I'm going to get 0. So this is where all of this comes from. What I then am going to do is substitute this in. So if I substitute in x equals 1 to start with, I'm going to get 6 lots of 1 squared plus 5 lots of 1 minus 2 equals. And then I know if I substitute 1 into here, this is going to cancel. If I substitute 1 into here, this is going to cancel. So the only one I'm going to focus on is b. This equals b lots of 1 times 2 lots of 1 plus 1. So I'm going to get 6 plus 5, which is 11 minus 2 is 9, equals 2 plus 1 is 3 times b, 3b, therefore b equals 3. Now if I substitute in x equals minus a half, I'm going to have 6 lots of minus a half squared plus 5 lots of minus a half minus 2. No, I don't need a bracket there. Equals, now, if I substitute in a minus a half here, I know I'm going to get 0. Minus a half here, I'm going to get 0. It's going to be c. So c lots of minus a half minus 1. So now, okay, let's see if I could do this in my head. Right, minus a half squared is a quarter times 6. So I'm going to get 6 over 4 minus 5 over 2 minus 2, which equals minus a half minus 1 is minus 3 over 2. Minus 3 over 2 times minus a half is positive 3 over 4c. So that means that 6 over 4 minus 10 over 4 is minus 4 over 4 minus 8. Oh, minus 4 over 4 is a whole one, isn't it? So we're going to have a whole 1 minus a whole 1 minus 2. Do we get minus 3? Oh, I've confused myself. So 6 over 4 minus 10 over 4. Yeah, I get minus 3. So I get minus 3 equals 3 over 4c. So therefore, c equals negative 4. Please correct me if I'm wrong. Then if I substitute in x equals 0, I'm going to have 6 lots of 0 squared plus 5 lots of 0 minus 2 equals, now which one am I going to focus on? And it is going to be a, because if I substitute 0 into here, I'm going to get 0, 0 into here, I'm going to get 0. So that means I'm going to have a lots of 0 minus 1 times 2 lots of 0 plus 1. So I'm going to have minus 2 equals minus a, therefore a equals 2. So for my final answer, we have to write this all out. 6x squared plus 5x minus 2 over x lots of x minus 1, 2x plus 3 equals a, which is 2 over x, plus b plus 3 over x minus 1, and then our c is negative 4, so we're going to get minus 4 over 2x plus 1. And this is our final answer. What we're going to do now is we're going to do this again using comparing coefficients. So I'm going to have the same 6x squared plus 5x minus 2 equals a lots of x minus 1, 2x plus 1, plus b lots of x, 2x plus 1, plus c lots of x, x minus 1. Okay, so what we're going to do is we're going to expand everything out. So for the first part, now you can see this one's going to take a little bit longer, but let's see how long it does take us. So 2x squared, so a lots, no, I'm just going to expand it all out. Right, 2ax squared, because I've done that. Then I'm going to have minus a. Then I'm going to have minus 2x plus x is minus x, so this is minus ax. Then here essentially I've got bx multiplied by 2x is plus 2bx squared, and then plus bx. Then here I'm going to have cx, so I'm going to have plus cx squared minus cx. So now what I'm going to do is rearrange this. So all my x squared, so my x squared is here, and I'm going to have a look for my coefficient of x squared. So I've got 2a, I've got 2b, and I've got c. So 2a plus 2b plus c. Okay, I'm just going to cancel out my x squareds. Then for my coefficients of x, I'm going to have plus x, and then I'm going to have minus a plus b minus c. So here, minus a plus b minus c, and then I have minus a. So this needs to be completely equivalent to 6x squared plus 5x minus 2. So we can clearly see that 6 equals 2a plus 2b plus c, because those are my coefficients. That's my coefficient of x squared. I'm going to have 5 equals minus a plus b minus c, and again my coefficient of x is 5. And then I'm going to have minus 2 equals minus a. So from this we can clearly see that a equals 2. So now I'm going to have, if I substitute in 2 into the first one, I'm going to get 4, so I can move the 4 to the other side. So I'm going to have 6 minus 4 is 2 equals 2b plus c. In here, if I substitute in 2, I'm going to have minus 2. If I put this over to the other side, I'm going to get 7. So I'm going to get 7 equals b minus c. I'm going to add them together. 9 equals 3b. So therefore, b equals 3. And then to find c, I can substitute that in to this one. 2 times 3 is 6. 2 minus 6 is minus 4. So therefore, c equals minus 4. Now we haven't finished yet, because then we have to write 6x squared plus 5x minus 2 over x minus 1 to x plus 1 is completely equivalent to 2 over x plus 3 over x minus 1 minus 4 lots of 2x plus 1. And there we have it. 2 different methods providing the same answer. Okay, so here we go. Here is a question to test your understanding. Now, I'll just give you a clue. In this question, they haven't told you what is going to be on the other side. But we know this is going to be completely equivalent to what? It's the same thing. We're going to have a over 2x minus 3 plus b over x plus 2. Okay, off you go. Okay then, so very, very quickly, I'm going to have 5x plus 3 equals a lots of x plus 2 plus b lots of 2x minus 3. Now I'm going to use substitution. If I let x equal minus 2, I'm going to get minus 10 plus 3 is minus 7 equals b lots of minus 4 is minus 7b. So therefore b equals 7. And then if I let x equal positive 3 over 2, I'm going to have 3 over 2 times 5, which is 15 over 2, plus 6 over 2 is 21 over 2. Sorry everyone, this is a 1. And then if I substitute in 3 over 2, I'm going to get 15 over 2 plus 6 over 2. Okay, 21 over 2 equals 7 over 2 times a. So that means a equals 3. So, therefore, we're going to have 5x plus 3 over 2x minus 3, x plus 2 is completely equivalent to 3 over 2x minus 3 plus 1 over x plus 2. Okay, so here we have some questions. What I would like you to do is give them a go. For question 2, you can see here, factorise the denominator first. So we've got some easy questions here, which you might have to factorise the denominator. You see we've got difference of 2 squares, okay? And then we've got some a little bit difficult here, especially with this negative, but don't let that, you know, make you feel uncomfortable. So yeah, maybe try and do one from each category or see how many you want to do. Off you go. Okay, so we're going to do 2c together because it clearly says factorise the denominator. But if we look at 2a quickly, we can clearly see here, x cubed minus x, I can factor out an x. So I'm going to get x squared minus 1. Now x squared minus 1 is also difference of 2 squares. So then this can be factored out again to x plus 1, x minus 1. Now for the part C, here we are. How on earth am I going to factorise this? So what we actually need to do is we need to find a factor for the denominator. So don't know if you remember back to pure 2. Okay, I'm going to substitute in some values to see if it's a factor, and then I'm going to use algebraic division. So if I let x equal 1, for example, okay, that means I'm saying that x minus 1 is a factor. Now let's see if this is true. If it is a factor, this means f of 1 is going to equal 0. So it's taken us all the way back to pure 2. So we're going to have 1 cubed minus 4 lots of 1 squared plus 1 plus 6 equals 0. So 1 cubed is 1, minus 4 is minus 3, plus 1 is minus 2, plus 6. 4 does not equal 0. Okay, so that's not a factor. Okay, if we try x equals minus 1, that means x plus 1 is a factor. So let's try minus 1. If this is a factor, the function of minus 1 should equal 0. Minus 1 cubed minus 4 lots of minus 1 minus 1 plus 6. Oh, sorry, this is squared. Equals 0. Minus 1 cubed is minus 1. Minus 1 squared is 1. Minus 4 minus 1 plus 6 equals 0. Okay, 0 equals 0. X plus 1 is a factor. So, sorry, now what I'm going to do is algebraic division. So I know that x plus 1 is a factor. So I can divide this. Now you may need to be able to do this in the exam. So it's really good that we run through it. Now I have already put a video on YouTube of how to do this. But what I like to do is I'm a silly Billy. Okay, and you write down the side, IMSB, I'm a silly Billy. So then you say to yourself, into, how many x's go into, and this is our into x cubed, and it is x squared. We then multiply down, so x squared times x cubed, x squared times 1, plus x squared. S stands for subtract. We're going to subtract these. Now, you know you're right if the first two terms, x cubed minus x cubed, equals 0, and they do. Minus 4x squared minus x squared is minus 5x squared. And then B stands for bring down. So then we're going to bring down this x. And then what we do, we start all over again. So now we say into, how many x's go into minus 5x squared? That is, in fact, minus 5x. Then minus 5x multiplied by x is minus 5x squared. Minus 5x multiplied by 1 is minus 5x. So there, I've multiplied. Now I'm going to subtract. Minus 5x squared minus minus 5x squared, 0. X minus minus 5x is 6x. And then bring down. Sorry, this looks like a C, but it's definitely supposed to be a 6. And then I say to myself, okay, x goes into 6x how many times? Plus 6. And then we multiply, we're going to have 6x, and then 6 times 1 is plus 6. Now we know we should have a remainder of 0 because x plus 1 is a factor. So that then means that x cubed minus 4x squared plus x plus 6 is completely equivalent to x plus 1 bracket x squared minus 5x plus 6. Now again, I need to factorise this one more time. So I'm going to get x plus 1 to fully factorise. Two numbers that multiply to give me 6 but add to give me minus 5, minus 3 and minus 2. So there we have it. We have now fully factorised this. Now I know that 5x squared minus 15x minus 8 over x plus 1, x minus 3 and x minus 2 is completely equivalent to a over x plus 1 plus b over x minus 3 plus c over x minus 2. And then we can start the question from there. So this is just a bit of an extra step before we start the question. So, repeated linear factors. Suppose we wish to express this as a over x plus 1 and b over x plus 1. What would happen is when we would multiply everything by x plus 1 squared, you know when we did before, when we had our substitution, we'd have like a x plus 1 plus b x plus 1. And then as soon as I substitute it in, oh, where has that gone? As soon as I substitute in x equals minus 1, I'm going to get 0. So I can't actually find out what my A or B are. So this doesn't work, okay? So what we need is we need the denominators to be different. So what we do is this. In the example here, we have 11x squared plus 14x plus 5 over x plus 1 squared to x plus 1. So we split it like this, x plus 1 and b over x plus 1 squared. So here, we'd be able to split this as x plus 1 and then b lots of x plus 1 squared. Okay? So, how we do this, nice and easy. Again, I'm going to do substitution, but if you want to use comparing coefficients, please go ahead. So, I'm going to have 11x squared plus 14x plus 5 equals. Now, I'm going to multiply this denominator by each one of these, and I'm not going to show you step by step, but if I multiplied a over x plus 1 by this, I'm going to be left with a lots of, oh, my battery's gone. Okay, back again. So we're going to have a lots of x plus 1 to x plus 1 plus b lots of, now again, if I was to multiply this denominator up here, the x plus 1 squares would cancel, so I'd just be left with 2x plus 1 and then plus c lots of, and again, if I was to multiply this by c, I'd be, the 2x plus 1s would cancel, I'd have x plus 1 squared. So, in this case, I only have two substitutions. So I'm going to substitute in x equals negative 1, and I'm going to substitute in x equals negative a half. So when I substitute in x equals negative 1, I'm going to have 11 lots of negative 1 squared plus 14 lots of negative 1 plus 5 equals. Now, my a is going to cancel to give me 0. My b, 2 lots of negative 1 is negative 2 plus 1 is negative 1. So this actually gives me negative b. And then my c, when I put in negative 1, I'm going to get 0. This is going to cancel. So I just need to, 11 times minus 1 is minus 11. Minus 11, no, that's so wrong. Right, minus 1 squared is 1 times 11 is 11. Minus 14 plus 5. So I'm going to get 16 minus 14, which is 2. So 2 equals minus b, therefore b equals negative 2. Perfect. If I substitute in a half, I'm going to get 11 lots of negative a half squared plus 14 lots of negative a half plus 5 equals. So if I substitute in here, a lots of, and then my negative a half, my a is going to cancel, okay? Here, negative a half, my b is going to cancel. If I substitute in here, now this is a bit different. I'm going to get c lots of negative a half plus 1 squared, okay? So, what we're then going to do is we're then going to have negative, right, I'm going to have 11 over 4 minus 7 plus 5 equals, a half squared is a quarter, so c over 4. Okay? So then, 7 over, in terms of quarters, sorry everyone, I don't have a calculator on me right now, but I've got this. Right, 7 in quarters is minus 28 over 4. 5 in quarters is 20, so this is going to become 31 over 4, which is going to leave me with 3 quarters equals c over 4. So therefore c equals 3. Okay, we still have a slight issue here because I haven't actually figured out what a is. Now this is where it would actually be easier for me to compare coefficients. Okay, we could try substituting in different numbers if we wanted to, and we could substitute in 1 into everything. So there's 2 ways we can do this. So way 1, pick a number, preferably something easy. So if we let x equal 1 and we substitute into this the whole equation, okay, we already know what b and c is, so we're going to be able to figure out what a is. I'm going to have 11 lots of 1 squared plus 14 lots of 1 plus 5 equals a lots of 2 lots of 3 plus, now our b is negative 2, so negative 2, and then if I substitute 1 into here, I'm going to get 2 times 1 is 2, plus 1 is 3, plus our c is 3, lots of 1 plus 1, which is 2 squared, lots of 4. So I'm going to have 11 plus 14 is 25, plus 5 is 30, equals 6a, minus 6 plus 12 is plus 6. So then I'm going to have 24 equals 6a, so a equals 4. So there's one way to do it. Or way 2, what I could do is I know that my a is going to be compared to my 11x squared, isn't it? So the coefficients, so I have 11x squared. Where else am I going to get an x squared? Now, if I look at here, if I was to expand this, I know I'd have here 2x squared a. Okay, then if I expand the b, I'm not going to get any x squareds. If I expand the c, I am going to get, this is going to be an x squared, so I'm going to get cx squared plus cx squared. Now I can cancel on my x squared, so I get 11 equals 2a plus c. My c is in fact 3, so 11 equals 2a plus 3. That means 8 equals 2a and a equals 4. So there we have 2 different ways. Again, it really doesn't matter which one. Now finally, you know what we have to do. We have to write the whole thing out again. 11x squared plus 14x plus 5 over x plus 1 squared bracket 2x plus 1 equals, our a is 4 over x plus 1. Our b is minus 2 over x plus 1 squared, and our c is plus 3 over 2x plus 1. Okay, time to test your understanding. So exactly the same principle. I'm going to give you a few minutes. Off you go. So first step, if I multiply everything by the first denominator, I'm going to get x squared equals. Now if I multiply a by this, only one of the x minus 1 is going to cancel, so I'm going to be left with a lots of x minus 1, 2x plus 1. Then if I multiply b by the denominator here, the x minus 1 squareds are going to cancel, so I'm going to be left with 2x plus 1. Then if I multiply by c, again the 2x plus 1 is going to cancel, so I'm going to be left with x minus 1 squared. So now I'm going to choose x equals 1, because that's what makes this bracket 0, and I'm going to choose x equals negative a half, because that's what makes this bracket 0. So then I'm going to be left with 9x squared, which is 9, equals a lots of x minus 1 that's going to cancel, my c is going to cancel, but my b, I'm going to have b lots of 2 lots of 1, which is 3, so therefore b equals 3. When I substitute in minus a half, I'm going to have 9 bracket minus a half squared equals, now again my a is going to be completely cancelled, my b is going to be completely cancelled, it's just going to have my c lots of negative a half, negative 1 squared. So I'm going to have 9 over 4 equals Minus a half minus 3 is minus 7 over 2. No, because that's wrong. That shouldn't be a minus 3. This is a minus 1. It's minus 3 over 2 squared. Minus 3 over 2 squared is 9 over 4. 9 over 4c. So therefore, c equals 1. Now what I can do, again, is I can either choose a random number or I can equate coefficients. Now here, it's just an x squared, so I know I'm going to have 9x squared equals, if I was to expand this, what would I get? And again, I'm going to add, my x is multiplied by 2x, which is 2x squared, lots of a. Then I'm going to have, my b is only going to multiply by 2x, there's no x squared here. And then this is going to have x squared, so I'm going to have cx squared. So this means 9 equals 2a plus c, which we know is 1. So 8 equals 2a, so therefore a equals 4. I can now, my final step, write it all down. 9x squared over x minus 1 squared, 2x plus 1 equals a 4 over x minus 1 plus b, which is 3 over x minus 1 squared plus c, which is 1 over 2x plus 1. So you need to go to exercise 2b. Exercise 2b, okay? I'm going to do questions 1 to question 6. Oh, golly. There we go. Question 1 to question 6. So, dealing with improper fractions. Now, an improper fraction in terms of algebra is where, for example, the highest power of 2 on the numerator is the same or more. Okay, so here, not the highest power of 2, sorry, the highest power of x. For example, we have an x squared on the top. I can't believe I said that, on the numerator. So we can see here, the degree on the top is 2 because x squared is the highest power. On the denominator, the highest power of x is 1, so the degree is 1. So if the degree is higher on the numerator or the same as the denominator, we call this an improper fraction, okay? So when we have improper fractions, we're able to split them up. For example, if you had 9 divided by 4, well, actually, this is 2 whole ones, remainder 1 over 4. So this is what we're going to be looking at. So here we go. Here we go. We have another example here. 7 over 3, it's the same as 2 and a third, which is the same as 2 plus a third. So what we're going to do is we've got to go back to our favourite, and our favourite thing is, in fact, I'm a silly Billy. So to reduce it for this type of question, all we're going to do is write down our favourite acronym, I'm a silly Billy, and we're going to divide. We're going to have polynomial division. And what we're going to find, x squared plus 5x minus 9. So how many x's go into x squared? The answer is x. I then multiply x by, wrong way round, x. X times x is x squared. X times 2 is 2x. I'm going to subtract them. 5 minus 2x is 3x. Bring down minus 9. How many x's go into 3x? I'm going to get plus 3. And then I'm going to have 3 times x is 3x. 3 times 2 is plus 6. They're going to cancel. Minus 9 minus 6 is in fact minus 15. So that means when I divide this, my quotient is x plus 3. So x squared plus 5x minus 9 over x plus 2 equals x plus 3. And my remainder is minus 15 over the original denominator, x plus 2. So again, we're going to do this question here. Test your understanding. Just a word of caution. Remember, on the denominator here, we have x squared minus 4. We're missing out the degree of just x. So when you're dividing, we're going to have x squared plus 0x minus 4. Okay, please make sure you do that so that your division works out properly. Then you're going to have 3x to the power of 4 minus 2x cubed minus 5x squared minus 4. And again, I'm a silly Billy if you've forgotten. So how many x squareds into 3x to the power of 4? And this is 3x squared. Okay, so that's where I'm going to write it. And then this is my into, now I multiply. So I multiply 3x squared by every term. So 3x squared times 3x squared, 3x to the power of 4. You know you're right if these are going to cancel. 3x squared times 0x is 0x. Essentially it'd be cubed, wouldn't it? This is why it goes here. Then 3x squared minus 4 is minus 12x squared. I'm now going to subtract these. 0 minus 2x cubed minus 0 is just minus 2x cubed. Minus 5x minus minus 12 is 7x squared. And then we're going to bring down the minus 4. Now I say to myself, oh, I've written I'm a silly Billy wrong. Why didn't no one tell me? I've put I'm a Billy silly. So then, now I say to myself, right, how many x squares go into minus 2x cubed? And it is minus 2x. And guess what I've forgotten to do here? This is not a minus 4 at all. How silly of me. We don't have an x term. So this is plus 0x minus 4. So this is the term I'm bringing down, plus 0x. So, start again. How many x squareds go into minus 2x cubed? It is minus 2x. Minus 2x times x squared is minus 2x cubed. Minus 2x times 0 is plus 0x squared. Minus 2x times minus 4 is plus 8x. Now we're going to subtract. You know you're right for the first two terms, take away. 7 minus 0 is just 7x squared. 0x minus 8x is minus 8x, and then we're going to bring down our minus 4. Now it's okay if you make a mistake like I just did in the exam where I didn't spot that there was the coefficient of x missing, because as we did it we then spotted that mistake and rectified it, so that's completely fine. Now I say to myself, how many x squareds and 7x squared? The answer is 7. Then I multiply 7x squared plus 0 lots of x. And then minus 4, 7 times minus 4, minus 28. Take them away. 7x squared minus 7x squared is 0. Minus 8x minus 0 is just minus 8x. Minus 4 minus minus 28 is plus 24. So therefore, we have our quotient and our remainder. So 3x4 minus 2x cubed minus 5x squared minus 4 all over x squared minus 4 is completely the same as 3x squared minus 2x plus 7. And then I am going to write this as plus 24 minus 8x over x squared minus 4. Okay? And this will give you full 4 marks. Maybe if I just move... Oh no, I can't, it's attached. Okay. Right then, so there are actually 2 ways that you can deal with improper fractions. Sometimes it is easier to divide, sometimes it's easier to use one identity, okay? And I'll show you what I mean by that in a second. So we can do our algebraic division. To do that first though, we need to make sure that our denominator is in fact multiplied out. So x times x is x squared we're then going to have minus 3x and plus 2. Okay? Now I can use algebraic division. Now if I was to use algebraic division, I'd get x squared minus 3x plus 2 into 3x squared minus 3x minus 2. Remember, I'm a silly Billy. So I would say, how many x squareds into 3x? The answer is 3. Then I do 3 times x squared is 3x squared. 3 times minus 3 is minus 9x. 3 times 2 is 6. I'd subtract them. First term goes minus 3x minus 9x is 6x. Minus 2 minus 6 is minus 8. So therefore, that means the answer is 3 plus 6x minus 8 all over our denominator, x squared minus 3x plus 2. Now from there, what do I do? Well, I know that x squared minus 3x plus 2, if I put this back into the original form, factorised form, x minus 1, x minus 2, this, I could say, let 6x minus 8 over x minus 1, x minus 2 equal a over x minus 1 plus b over x minus 2. And then we're going back to, well, where we were at the beginning of the chapter. So I then know that 6x minus 8 equals, and I'm going to have a lots of x minus 2 plus b lots of x minus 1. Now here you can use substitution or comparing coefficients. I really do not mind. So if I was to use let x equal 1, I'm going to get 6 minus 8, which is minus 2, equals a. 1 minus 2 is minus 1, so this is minus a, so a equals 2. If I let x equal 2, I'm going to get 12 minus 8 is 4 equals b. So my b equals 4. So therefore, my final answer is this number 3 plus, now we know this is going to be broken up into 2 over x minus 1 plus our b, which is 4 over x minus 2. So this is how we've split this into partial fractions, okay? Now there is another method, and this method is using one identity, and I'll show you what that means in a second. And this method is actually preferred by the mark scheme. So number 1, you can do your algebraic division and then go back to doing partial fractions. Or number 2, we know that 3x squared minus 3x minus 2 over x minus 1, x minus 2 is going to equal. Now you can clearly see I've got 2 terms multiplied by each other. So I know this is going to be split into 2 fractions here. But because the power is the same or higher, I know I'm going to be left with a whole number. So what we write is, well, it might not be a whole number, sorry, a term that's not divided. So we're going to have a plus b over x minus 1 plus c over x minus 2, okay? And then what we do is we do the exact same thing that we'd normally do, where we multiply everything out. So we're going to have 3x squared minus 3x minus 2. I'm going to multiply everything by the denominator. So we're going to have a lots of x minus 1, x minus 2, plus b lots of, the x minus 1s are going to cancel, so I'm just going to get b lots of x minus 2, plus c lots of x minus 1. And now I'm going to substitute in x equals 1, and then I'll substitute in x equals 2. So if I substitute in x equals 1, I'm going to have 3x squared, which is 3, minus 3 minus 2, equals, if I substitute in x equals 1, this is going to be 0, and this is going to be 0. So I'm going to get b lots of 1 minus 2. This is then going to give me minus 2 equals minus 2. No. What's 1 minus 2? Minus 1? Yeah. So minus 2 equals minus b, so therefore b equals 2. When we substitute in x equals 2, I'm going to get 2 squared is 4 times 3 is 12, minus 3 lots of 2, which is 6, minus 2 equals, this is going to cancel, this is going to cancel, I'm going to be left with our c. C lots of 2 minus 1, 12 minus 8 is 4, 2, so c equals 4. Then how do I find my a? Because anything I substitute in here, remember there was those two methods there, I can either try substitution or I can equate coefficients. The only way I'm going to get x squared is by doing a times x squared here and 3x squared. So that means by comparing coefficients that 3x squared equals ax squared. So therefore a equals 3. Substituting this back into our form, we have a first, so that's 3, plus b over x minus 1, our b is 2 over x minus 1, plus c, which is 4 over x minus 2. So this is two different methods that yield the same answer. Okay, test your understanding. Please feel free to use whichever method you prefer. I'm going to give you 5 minutes. So we know the degree of power on the numerator is an x squared, and if we were to expand the denominator, we know this degree is an x squared. So our partial fraction, 9x squared plus 20x minus 10 over x plus 2, 3x minus 1 is going to equal a plus b over x plus 2 plus c over 3x minus 1. From here, if I multiply everything by the denominator, I'm going to get x squared plus 20x minus 10 equals a lots of x plus 2, 3x minus 1, plus b lots of, and when I multiply this up here, the x plus 2's are going to cancel. So I'm going to have b lots of 3x minus 1 plus c lots of x plus 2. So now from here, I'm going to substitute in my x equals negative 2 and x equals positive a third. If I substitute in x equals negative 2, the only one that's going to be affected is b, because this is going to cancel to 0, this is going to cancel to 0. So I'm going to have 9 lots of minus 2 squared plus 20 lots of minus 2 minus 10 equals b lots of 3 lots of minus 2 minus 1. 4 times 9 is 36 minus 40 minus 10 equals minus 6 minus 1 is minus 7. So I'm going to have minus 7b. 36 minus 50 is negative 14 equals negative 7b. Therefore, b equals 2. For x equals a third, I'm going to have 9 lots of a third squared plus 20 lots of a third minus 10 equals, now if I substitute into a, again, this is going to cancel, b is going to cancel, I'm going to be left with c. C lots of a third plus 2. A third squared is 1 over 9 times 9 is 1 plus 20 over 3 minus 10 equals a third plus 2 is 7 over 3c. So I'm going to have minus 9, 1 plus minus 10 is minus 9, minus 9 in a third is minus 27 over 3, so this is going to give me minus 7 over 3 equals 7 over 3c, so c equals negative 1. Now for A, what I'm going to do is I know I have 9x squared, and my A, the coefficient of x squared, is going to be x times 3x, which is 3x squared times A. So we're going to have 9x squared is the same as 3x squared A. So therefore A equals 3. So my final answer is 9x squared plus 20x minus 10 all over x plus 2, 3x minus 1, equals my A, which is 3, plus my B, which is 2 over x plus 2, plus my C, which is minus 1 over 3x minus 1. So what we're going to do is you've got an exercise to do. I'm going to give you about 15 minutes to do this. So the answers are here on this page. Please double check everything. So as a quick summary, what we're going to do is in the first case, we know that we have x, x plus 1 and x minus 1. So as partial fractions, we're going to have three fractions. We're going to have a over x plus b over x plus 1 plus c over x minus 1. For the second question, you need to spot that x squared minus 4 is in fact a difference of two squares. This is x plus 2 and x minus 2. So what our identity we're going to use is a over x plus 2 plus b over x minus 2. Then for part 3, what we have is a repeated root. So we know that our final answer is going to be a over, oh, bit of a funny a here, x plus 1 plus b over x plus 1 squared plus c over 2x minus 3. It's really important when we have that repeated root that we have one single bracket and then the squared version of that bracket. For the last one, we can clearly see that this is an improper fraction, okay? Because our highest power on the numerator is degree 3. Our highest power on the denominator is degree 2. So for this, we are going to have a quotient, and then our remainder is going to be over the two remaining factorised denominators. So we're going to have a plus b over x minus 3 plus c over x plus 4. So this is a kind of summary of when you look at the question, stop what you're doing, think about what it's going to look like, because I know in some exam questions they've given us this, but some of them do not.